Okay, let's try this again. I think we're connecting now. Let me double check. I'll log into Nano Hub, if I could spell. I'll log in. And while I'm doing that, let's check video and audio. Do we have audio? Sounds like something's happening. It's just catching up to me, right? All right, so I do have some audio. This is kind of it's playing through my speakers instead of my headset, but it is recording. Cool. All right, and then let's go into my dashboard and open this. So coming back into computational mechanics, I think right now most people are working on this second project for computational mechanics. And this is all about, this whole module is all about different ways of using Python to process data. One of the things that I saw that Copilot said a few times was like, you can use these things to manipulate data, but manipulating data sounds like you have some kind of motive, like it's a charged verb of like manipulating, as if you're like trying to change things to do what you want them to do. Here, really what we're trying to do is process and interpret data. So this is like using statistics and data processing to try to make sense out of lots of numbers. That's what we're trying to do. So I wanted to pull this up because there were a few things that I noticed like in the reading discussions with that learning coach of, it's like there were even questions that, like one of the questions that came up was like, why do you use pandas rather than NumPy to process data? And like, oh, I don't actually know. And some of the answers that AI was giving was like, because pandas is more powerful, or NumPy is only meant for doing like math on. It's like, well, yeah, kind of, but you could also do almost everything you can in pandas in NumPy. It's just sometimes it becomes like a little cumbersome. Sometimes people avoid pandas as much as they can just because they don't like the interface of using like pandas data frames. So let's pull up, we'll pull up homework 2 to start, and then go from there, because I think I have some of this. Yeah, I had done some of this work already. Looking at this. So like in this case where we create this transistor data set as a CSV, TRAN. It has all these different columns of data, and I can call like individual columns of like what was the processor that actually had that number of transistors, who was the designer. And in this case, I like it because when you're reading like the code, at least in this case where I'm looking at a for loop of like, okay, how did they make this plot, or how did I make this plot when I'm going back to, because the most likely person that's going to have to debug my code is me. Same thing with you. The most likely person that's going to like go back and look at your code and reuse it is yourself. So be kind to yourself. Use some reproducible steps that you can actually go back and trace. So that's why I try to name my variables things that I understand. Sometimes I'm not very creative. Like here, US and EU makes sense, but a lot of times I end up using T, X, and Y, and Z in a lot of places, but I should make them better variable names. Okay, but anyway, so let's let's look at some other ways of like getting this data into here and see if it's better or worse than using using pandas. So first thing to do is just understand what am I loading in here. So and this is the first thing that I asked you to do, was like get the head, just look at the first 10 lines of this file. And what I could do is just, actually, one thing that I used to do a lot was I would Google, how do I read a CSV file in Python? And this is one of the most common things that I would get when I was trying to find this. So let's, yeah, this is what I would get, is that in order to read a CSV, I have to open it and then go through every line of that CSV file, and it'll create a list of that thing. So let's try that out. So I want this CSV. And let's just do like the first 10 lines. Oh, yeah, I just wanted to do the first 10 lines, but it's showing me everything. And I'm trying to remember why that's the case. This was like a really weird way of doing things, because now, yes, I have in each loop, I have this data set called lines. It's a list of values, but it's really annoying because all of it's just assuming that everything is a what's it called? A string. Sorry, that's why it has quotes around it. And then it's putting in all these extra characters like this /XAO, XA0. I think that's a space. So yeah, and I have to go through this thing line by line. So this whole process is, yes, it's using Python. So it did answer my question of like, how do I read a CSV file in Python? Like, okay, yeah, you can do this, but it's a very awkward and it takes a long time to do. So I don't like that. So I never use this 4 lines in CSV file. And if you see someone's code, if you're looking for code, like, all right, how do I make this work? How do I read this CSV file? You'll see this a lot as if you're doing more Python work, but it ends up being a lot more work than necessary. You can do more stuff with it. Like I could say, all right, grab the second column or the second value of every one of these and save it to this list, like append it to a new list, and grab the third column, append it to a new list of all the dates. Fourth column, append it to all the designers. So I could kind of process my own way, but it's annoying. Like I need this for loop, I have to create this CSV file. And yeah, I think technically I have to close the file with it done once it's done. And yeah, it's this awkward kind of with open. So anyway, I don't like it. If you do like that, it's not that there's anything wrong with using it. I just find it very cumbersome to use. When meanwhile, read CSV is a single line, and I know exactly what it's doing. It's going to this data and loading it into np dot, I think load text. There we go. And when I try to do this, it's telling me, it gives me a long error, but the main thing is that it's having trouble saving these things into an array, and it's on the very first line, that processor MOS. That's why I always do the head of the data. So I can see, like, all right, where did it run into trouble? And it ran into trouble right at this spot, right when there was a space. So let's add something that says delimiter is a comma and see if that helps. And now it's also having a problem because processor is not it's a string, not a float. Okay, so then let's skip the first row. And now it's telling me that this MP944 20-bit is also a problem, which is in the first column. And now I have to look something up. Let's see. NumPy load txt skip columns, or use column. Maybe it's use columns. Yeah, use cols. So I could say use cols and load it into, let's see what the case is. Use calls, and I could give it what columns I want to use. So I don't want the first column. I do want transistor count. So I want column 1. So this is 0, this is 1. Then I want column 2. And I'm going to use designer, but I think I'll have to use that as a different. Let's see if this one gives us what we want. 6-chip. So transistor count and date of introduction. I don't know why it's giving me 6-chip. Oh, because there are commas in here. So this is also, Pandas does a good job of recognizing, like, okay, this whole thing is a string because it's all in quotes. But NumPy, as soon as it sees this comma, it's going to treat it as a whole nother column. And so can we just call this 2 and 3? 40 pin. So maybe 3 and 4. I'm just trying to skip over. So I might actually, if I want to use NumPy for this, I might actually need to, like, go in and change the format of this CSV. So 0, 1, 2, 3. Zero, 1, 2, 3. Wait, 0, 1, 2, 3. 0, 1, 2, 3. I think sometimes there's no comma here. It happens to be that these have commas in them, but I think sometimes there are, sometimes there aren't. And I don't know how to fix that with NumPy load text. But anyway, at least for me, that's the main reason to use read CSV, because it's such a powerful tool to get things into a Python format, even when it's like big weird tables full of like lots of data. Sometimes you need all that data, like in this case we needed all the designer names and all the years, and we needed all that transistor count kind of data. Oh yeah, the other thing that the readings were asking about were this the box plot. Like, what is a box plot actually showing? And I mean, that it was in the reading, so there, like, as we're coming in here, let's do a kernel restart run all, and we'll get rid of that. This coming back up, so I'm looking for these box plots. I know they're in here. Well, here's the quartiles, and there's our like box plots. So nice part about a box plot is that when we look at these histograms, histograms are a great way to see kind of all the data of like what's the most likely in this data set, what's the most likely thing to occur. Box plots are another way that, if you've seen histograms before, this is another way of looking at that same, it gives you the same information, except the nice part here is that it, instead of showing you up here small bars, because on this histogram it looks like, oh, we had a lot of beers that were between like 9% and 11 or whatever, 10.1%. But when I look in here, it's like, oh, those, everything above 10% was outliers. That was outside of my quartile range. That's what these little circles are. So based on the average and kind of the bulk values, it gives us a different view of that. And again, all of this is like data processing and data interpretation. We're not manipulating the data. It's not like I'm saying these outliers are here, so I'm going to delete them because they're outliers. We're just processing. Sometimes it makes sense to say this is an outlier, I should get rid of it. In this case, we're trying to represent like real data that's out there. There might be an outlier of like 50%. That's probably just a data processing, like a data entry error. That's different than just like a beer that has 12% alcohol. That's more of like, that's an outlier in that not many beers have that much alcohol. But here, the average beer is 5 point something percent. Lowest is 0%. And then IBUs is another one. That one I don't have as good of an intuition about. But we can see this is kind of, yeah, in that red label, the median is the median. And then we have these different quartile ranges of like, where was 25% of the data, 50% of the data was here and below, 50% is there, and then the 100% is below these outliers. And if it's outside that, and that's when it starts getting marked as those outliers with the circles. Yeah, first, second, third quartile. And it's a little different from what we were talking about in the homework in all right, so let's go back to the homework, because I think I have some work done in here where we were doing some Monte Carlo work. And I created this p-critical and I get this histogram full of data. But I could have also said, let's take that same histogram, box plot of PCR. Now I'm taking all this data, putting it into a box plot, and seeing that down here, this is saying 25% of my data, my first quartile, is down at this, and it's kind of hard to see where that is. lt.y scale log. Would that help? A little bit. So down here, maybe like 50 newtons, then by the time I get to 100 newtons, it's all up there. And then there's a whole bunch of stuff up here. But there are a bunch of outliers that are almost 1,000 newtons, so 500 to 900 newtons, something like that. And that's what this tail is showing me. So it's not that outliers are bad data, it's just that they're outside of these little quartile ranges about how we define them, that you're 25% up to 50%, 75%, and then by the time we get to the top, that now we have 100% of the data. So coming in here to there, all the way out to capturing all of those outliers. Yeah, so and I just wanted to come back in here because we calculated those percentiles, right? We were using interquartiles, yeah. We made like this, we use this percentile function here. And instead of IBU, I'll say PCR. Oh, do my fancy multi-cursor thing. So 117, 155, and 201. But I could also add this 2.5, and now I see that it's 64 newtons, which is lower than that 98. And then this is now my 25, I guess. The 2.5%. So this becomes 1, 2, and 3. So now I can see lowest 2.5% is 64 newtons or less. So that's lower than that 98 newtons. And I could grab this and try it again down here, like after we had figured out so now, taking those same values with that 4.1 Newton length, that lowest 2.5% is 96.9, first quartile 175, then 230, then 300. So at least half of our rods are 230 newtons or below, and that's double the weight. So even with a factor of safety of 2, Yeah, that's kind of how that factor of safety would work, is that if I say there's a factor safety of 2, I'm saying that this bottom 2.5% is probably about half of whatever I'm actually designing it for. And that's why we as engineers use like factors of safety of 2 or 3, because we know when we install something, if the manufacturer tells us like, yes, this will hold 230 newtons, we know like, okay, well that's 230 plus or minus like 60 or 70, depending on what the standard deviations are on these measurements. So a lot of what gets reported are average values. Sometimes you get a little bit more information about standard deviations, but that's what I really like about Monte Carlo methods, is that it gives you a way to sort of propagate this error. Like, I know things are going to change as I'm manufacturing things. How do I factor that into my analysis? And this is a good way to do that. And then it also gives you a little bit of insight into like, why do I have this factor of safety there? Yeah, so those were some of the reading questions that I thought were interesting. So the one thing that I wanted to bring back up, because some people maybe didn't know how to do this. So let's go learn, log in. Let's go back into our reading coach. So one thing that I noticed is that if I'm not logged into my UConn Microsoft account, then I can't access this learning coach. It'll tell me that I just can't do it because it's because it's UConn. It's a UConn license to have access to Copilot. Okay, so I'll open it up with my Microsoft at uconn.edu account, and if I take this reading quiz, one way to get what I'm asking for in the in this assessment. So let me close this out and put on student preview and show you like one way of taking this learning assessment quiz. So I could view the instructions, and then here's my submission. Every time it gives me a response, just copy that response and paste it in. And now, like, I could say skip it. And then gives me another response. I'll copy it and paste it in here. And so what I'm getting from this is like what questions it's asking, and also like what it thinks of your answer. It would be great to see what your answers are, but that's a whole nother step, because now I guess you could copy it in. I'd appreciate like your answers in there, but mostly I was trying to figure out like what is this system actually, what does it think we're trying to learn here? That's what I'm trying to figure out, of like, because it's not actually thinking. It's just like processing the data that I gave it based on this reading information. So let's see if I can answer this one now. Data set of beer ratings. I clean the data, use this line. What does it do? It replaces all NaNs. It removes only NaNs. It converts. So this one, this is what I think it does. It removes all the rows. Wait, all rows? No. It removes only. I'll try that. Drop all the rows that I think it would drop every row that has any column with an NA in it. Okay, so now I can grab that response and copy it in here. It's interesting, it went to a multiple choice question. I wasn't getting multiple choice questions before. I don't know what changed. Maybe they had a software update. So I'll submit this late. There are no late penalties in this class. I do ask that you keep me updated. If things are going to be late, I want to know when they're coming in. But I won't penalize any late submissions. So, okay. But that's what I was asking if you got a response that was like 90 out of 100, that's what I was asking you to do, is like copy and paste over you don't have to retake the assignment. You can go back to previous conversations that you've had and take a look at it. So here's a whole bunch of conversations that I've played around with in this case. All right, so that's all I had for today. Hopefully that was helpful, diving a little bit deeper into like why we're doing some of this stuff. Pandas, I really like it, but there are some people that really don't like it, even though they deal with data all the time. So I think it's a useful skill, and it's at least learning, like it's worth learning a little bit of, because you'll see it again. All right.